Okay, quick look up here. Close those up, have a quick look. So one issue that I wanted to real quickly do, yeah, that's fine. Yeah, I think you're fine with this, yeah. Okay, so what about a problem like this where we're trying to, we're trying to do an integral where clearly we need some substitution, right? What's probably the first thing you see up here where, what's one substitution you could make? Okay, good. So let's let u equal 1 minus 2x. So then what's du? Okay. So then what would we have if we made that substitution? And that's a great choice because that's the argument of both of the trig functions, right? So what's that going to give us if we make that substitution? We're going to get the integral of secant squared u tangent u, but what's the dx going to be? If I solve for dx, what do I get?
du over negative du.
Okay, so negative 1/2 du, okay? Okay, we still probably need a substitution there. Okay? Can you see a substitution you could make? And this is a good one to look at. This is a little tougher than the one they gave you in the assignment, but I want you to think about this a little bit here. Because you have to be able to account for both the, we'll call it a v, right? Because if we're going to make another layer of substitution, this will be a v substitution. What's v going to be? Because you have to be able to find v and dv to make a complete substitution. So you could choose tangent, right? If I choose v equals tangent u, what's dv? Secant squared u du, right? Okay, you see that there is another substitution you could make here. Right here, right? Because when you solve for dx would equal, here, I'll write it lightly up here. So dx would equal negative 1/2 du, right? And so here's my secant squared u tangent u, but then I've got a dx left over. Well, dx in terms of du would equal negative 1/2 times du, right? Okay. There is another substitution you could make here. Does anybody see it? You could use secant also, which is weird. It's weird, but what it tells you is that the areas under those curves, even though they look different, they're going to be identical. Okay. So if we make this substitution, then what do we end up with? So now we're going to have our negative 1/2 u, or v, sorry, dv, right? And what's the answer to that one? So what's the integral of v dv? V squared over 2, right? And I've also got my negative 1/2 out front, so I'm going to get negative v squared over 4 plus c, right? So then all we have to do is just reverse the substitutions to get back to x's, right? So if we reverse the v substitution to write it in terms of u, what do we get? Well, v equals tangent u, right? So we'd end up with minus tangent squared u over 4 plus c. And if we reverse it all the way out to an x, whoops, what was our original? U is 1 minus 2x. So we get minus tangent squared of 1 minus 2x over 4 plus c. So what's the moral of the story? You can do multiple substitutions if you want to. Could we have combined this into one big u substitution? Sure. Right? If we combine both of these, right, you could have said, okay, I'm looking way ahead here. I'm playing several moves ahead in my chess game. I could make tangent of 1 minus 2x be my original u substitution, and I could do it in one step, right? Is that better? I don't know. This is fine if you want to do it this way, right? Okay, make sense? Okay, last one. What about this? So what if we're trying to find the minimum n for which the error in the trapezoidal rule for this area is less than 1/10,000th? Okay. Actually, what is that? Is that 1/10? That 100,000th. Okay, so this is not a big deal, right? We have to use the error formula, but the part of the error formula that's going to be tough here is going to be the absolute value of the second derivative, right? We know that if we use the error formula, we'd have b minus a cubed over 12n squared times this monster. Right, the maximum of the absolute value of the second derivative on our interval. That all has to be less than 0.00001, right? Okay, this stuff's easy to calculate, no big deal, right? This is a little tougher, right? So if we were to take a second derivative, f of x is cosine of x squared. What's f prime of x? So we're going to get, say it again. Negative sine x squared times the derivative of x squared, which is 2x, right? Okay, here, we'll pick this one up tomorrow. Just finish this one little one up. Then I think that's the last thing we have to cover.